In this video, I'm going to present you how you're going to finish the first task of the buffer overflow attack. You have a folder called lab2, and make sure that you have these two files ready. One is exploit.c. This exploit.c is to create a file that contains the code. This is the shell code, okay, that are going to launching a shell. The stack.c is the program that has a buffer overflow vulnerability. Our task is to exploit this vulnerability. When we open the file, the bad file that is created by the exploit.c, and then they will cause a buffer overflow. The buffer overflow, we are going to insert our code into the buffer, and then we're going to launch the code injection, that is a buffer overflow attack. Let's go back to our terminal here. Then we have lab 1, lab 2. First we are seeded to the lab 2 folder. First, we need to turn off the address randomizations, because this is the mechanism that they built in the Ubuntu. They have the address randomization. If you do not turn it off, our lab cannot be successful. So we turn off the address randomization. So sudo okay. And next, step 2 will compile the stack.c by turn off another two countermeasures. One is executable stack, and the other one is FNO stack protector. Okay, and then we change the owner to root. Okay. Then the next in the next task, we're going to compile. We want to calculate the distances, so that we are able to insert the code into the right position. Into the right position. So basically, that we want to insert the code so that it will not contaminate the EIP register. As I mentioned, EIP register store the address of your code. You don't want to you don't want to overwrite that part. So you just want to put the code that is everything that above the EIP register. So what I'm going to do is to calculate, calculate where is the EIP, well, can we put the code into the EIP register. To do this calculation, what we will going to calculate the distances between the buffer and the EBP register. So after we get the distance between the buffer and the EBP register, we're able to know the EIP register. Okay, where is the EIP register? EIP register just the 4 bytes of the EBP register. Okay. We need to compile we need to compile the debug version of stack.c. And then we start debugging. gdb stack bg bof. Okay, we set a breakpoint. Run p buffer. And then we are able to know the EBP register. Oh, I'm sorry. That should be the symbol is EBP register. Okay, yeah. And okay, so right now that you know the addresses of the EBP register and the buffer, okay, so in these cases you know that how far is from the EBP register and to the buffer, okay, to the buffer. Right now that you know that the EBP register, the address is 108 at BFFF 108. I mean the buffer address and EBP register is the 0xBFFF 128. Then we will open up Python to do a calculation. We know the actual distances from the buffer to the EBP register. Look at the pictures here. We can see that the buffer address and the EBP register, the distance between these two, that 20 bytes. We should put our code at least that above the EIP register where is the return address is. Okay, so we know that this is EBP register, and then the EBP register is 4 bytes off. So our code, okay, our code should at least put into here. Okay, put into here. Yeah. So the address should be the buffer address plus 28 bytes. Okay, 8 bytes. That is at least where our code is. Yeah, at least where our code. Yeah. And however, in this bat file, we have inserted several knob instructions as the beginning of the file, so we can put our code that is way more beyond the 28 bytes, so it can be put more beyond that. Okay. Maybe we can just think about an address that is beyond 28 bytes. So we can just say about 128 bytes. So what I put it here. So we can think about the address is 230. Yeah, that is where we want to put our shellcode. So that is should put our shellcode in somewhere. Okay, so this is shellcode put somewhere. Okay, then we just open our stack.c. Okay, no, sorry, exploit.c. Okay, we need to fill our contents here. Yeah. So what we are going to fill out is we first want to place the return address. That is where our EIP register is. Okay, so you can take a look at the pictures here. So where our EIP register is the return address is, right? So this is the where is our EIP register. EIP register, the location is buffer plus the return address. Okay, return address. Okay, so this is where our EIP register is. Okay, and we want to put what we're going to put in the EIP register. EIP register will contain the address where the code is. We just do a calculation. We can put our code that is it's about 100, about the 230, right? 230. Yeah, that is beyond, far way beyond the EIP register. Okay, so we can continue edit our exploit.c. Okay, 0x bfff f230. Yeah, what we have calculated is 230. Yeah, so this is the address of our code, and this is our return address, where is the content of the EIP register. Okay, and also that we also need to write a code so that we are place the shellcode towards end of the buffer. memcpy buffer plus size of buffer minus size of shellcode shell. Okay, right now we have finished that. Then we're going to save it. Semicolon here. Create this. Then we're going to compile exploit.c. cc exploit c. Okay. Okay, sorry, there's something wrong here. I just fix it. So there should be 1 star. Okay, do that again. Okay, we're going to run exploit. You will see the bat file generated, and then we're going to run stack. You can see that we have obtained a shell. So you can see that this is inside a program. We can do ls, we can do as like a shell program, like what we did in the terminal here. We can do like other cd, okay, pwd, or cd to labs cd, okay. So that's it. That is for the task 1. Yeah. If you don't make it successfully, you will not able to see this kind of like the screen showing that we have obtained a shell. So make sure that you are not confused that this is inside this stack.c program. Yeah. Inside this stack.c program, you are running a program. It's a shell program. You are able to do like what you are doing right now in the